Hello chemistry fans, and welcome back to Chemistry 1032 problem solving session here at the Academic Success Center at Broward College North Campus. I am your host, Dr. Russell Betts, and I will be leading you through this problem today. Let's take a look. How many neutrons will the following atoms have? Okay, so now we have atoms written in different kind of symbology that you may not have seen before. It's very, very simple. Please don't be intimidated by it. Here we have element Be, that's beryllium. So let's take a little close look here. We have a 9 superscripted to the left and a 4 subscripted to the right. Well, let's clarify what these numbers are. This is a mass number. It will always be the mass number. Superscripted on the left, that number is the mass number. This is the atomic number. Okay? Subscripted to the left, that is the atomic number. Sometimes you will see the elements written out like this, giving you the mass number in the symbol. So now, the question clearly states it wants to know the number of neutrons. So it's a very simple question as long as you knew what that was and what that was. Okay? So the superscripted to the left, that number is always the mass number. Subscripted to the left, that number is always the atomic number. So the mass number equals the number of protons plus the number of neutrons. I just abbreviated protons and neutrons to their single letter. So the number, let's do it this way, number of neutrons equals the mass number minus the number of protons. So that's what the number of neutrons will equal. So now once we've figured out what these two numbers are, this question becomes rather simple. Mass number is 9 minus the number 4. And again, I'm positive you can do this in your head, but for the sake of the video, we'll do it on the calculator. 9 minus 4 equals, of course it equals 5. So the number of neutrons in this particular element of beryllium is 5. Okay? Fairly straightforward question, I think. All right. The next one. Uranium, superscripted 232. But now, throwing a little bit of a quirky monkey wrench into this thing. There is no number subscripted to the left. That's not a big deal, because that's just the atomic number, right? Sometimes that's left out, because it's simply the atomic number. All you need is our friend the periodic table. It's element U, that's uranium. Element U is down here. There it is right there, uranium. Uranium has an atomic number of 92. So you could just write it in yourself. So we can just put a 92 right here. You don't have to write that in there, but if you want to help yourself remember, simply write it in there. So keep in mind, sometimes the atomic number will be given, sometimes it won't be. It's up to you to remain calm, get out the periodic table, and just find the atomic number. Now, the question wants to know the number of neutrons. So the number of neutrons equals the mass number minus the number of protons equals. Mass number is 232 minus 92 equals, got the calculator, 232 minus 92 equals 140. So the number of neutrons in that element, or that atom, of uranium is 140 neutrons. All right, let's do one more just to clarify and just hopefully confirm everything we're doing. Now we have nickel 60. So we have a mass number of 60 on the nickel, nothing written for the atomic number, but we have a table. Find nickel. Nickel's right here. Nickel has the atomic number of 28, which means it has 28 protons. So let's write that down here. Again, you don't have to write the atomic number here if you didn't want to. I'm just doing it to make sure we're all remembering if it is given, like it is in the top question, it's the atomic number. Okay? Number of neutrons equals the mass number minus the number of protons. So it's going to be 60 from here minus 28 equals, again, let's just crank out the calculator so we don't make any silly mistakes. And that's 32. So the number of neutrons in that atom of nickel is 32. Well, I hope you found that helpful, and I hope you find this question easy to do now. If you have any further questions, please contact one of the tutors here at the Academic Success Center, or come on by your professor's office hours and get it straightened out with him or her. And with that, I'd like to wish you good luck and good chemistry.